are you, Frank? Welcome to my video submission for my low-level assignment project. I'm recording this video. I'm using the screen recorder function on the iPhone, and at the moment I'm screen recording the camera. So you're seeing the camera through the screen recorder of the iPhone, and so I'll show you the program quickly, or I'll run through the program, and then I think I'll run it and I'll show you the serial or the terminal, and then I'll swap from the camera here onto my BLE scanner and I'll take a few readings of that, and then I'll swap back to the camera and I'll show you the terminal again to show you that the BLE scanner is working. So to run you through the code, what I started by, I added my accelerometer characteristics to my step count program. Just these are all the libraries included. I've included a few libraries there for the timer. Time.h, unist.h, sis/time.h, lsm303, ll.h. Just to quickly run you through the characteristics. The first structure, a Bluetooth connection. Active connection is null. Uses to maintain a reference to the connection with the central device. Obviously that's used to maintain a connection with my microbit. Accelerometer characteristics. The matrix UUID is defined, the variable for Bluetooth matrix UUID is defined, and then it's set here as a structure, as a 1 to 8-bit structure. Matrix is set as 1 times 32-bit integer. I have to read matrix structures here, and then print k got a matrix read, and print k got matrix write. That will happen with the BLE scanner. So that's reading and writing values into the LEDs of the microbit, the LED matrix. Service definition for the matrix. Now the characteristics for the accelerometers. First one, they're all the same. So the first one is for the x-axis, so it defines the UUID of the accelerometer on the x-axis of the microbit, and then it sets that as a structure, and then an unsigned 32-bit integer, and then I have 2 reads, and then printf got an accelerometer read, and then it prints the accelerometer value. You'll see that on the BLE scanner, and then the same for the y-axis and the same for the z-axis. Now the step counter characteristics. So it's defined the UUID of the step counter of the microbit. I set that as a static structure and an unsigned 32-bit integer, and then I have a read step count and write step count static structure again, or as well. And callback that is activated when the characteristic is read by central. So when this is read by the central, by the microbit, prints got a read and prints the step count value, and it points to the step count value in the memory. And it does the same for when it's write, prints got a write, and it prints length of the step count value taken from the memory. And now arguments. It's showing when it's subscribed and not subscribed. Advertising configuration. Static constant structures. Now connected and not connected. So if there's an error will be printed here. If static void connected structure Bluetooth connection is not connected, it will print the unsigned 8-bit integer error, and it will print connection failed on the error message. And if there's an error, or else it will print connected and active connection will be connected. And static void structure disconnected, so when it's not connected, it will say disconnected and give the reason for not being connected. The camera's not focusing. Structure used to pass connection callback candidate to BLE stack, and this is called when the BLE stack has finished initializing. So when the Bluetooth has initialized, it will say Bluetooth initialized. Start BLE advertising using the ad array defined above. Advertise initializing. So if there's an error again, it'll print the error message. It'll print advertising failed to start and the error message. Otherwise, it will print advertising successfully started. Now we're into the main. So the integer error is defined. Old step count and error is set as LSM 303 LL begin. Those step count old and button A old and button B old, I think they were already there for the dump flash. I haven't integrated the dump flash into my main program. So if error is less than 0, then there's been an error initializing and an error code will pop up. And then after that error, button Bluetooth enable is null. From there, if there's an error, then that means the Bluetooth initializing has failed, and the monitor will print a message saying so. And then after that, if there is an error, the serial monitor will print Bluetooth ready, as if to say, well, as advertising that the microbit is ready for a connection. And it will print case for microbit 2. So that was, when it's connected, it will say, it will print Zephyr microbit v2 minimal BLE example. And now if the LSM 303 is the accelerometer, it's the name of the accelerometer, that's what's being defined here. When the error comes in, the step counter begins. If the count steps value of the LSM 303 step count value is less than 0, then that means there is an error, and I print an error. And from there, we're getting into sort of the while loop where I've put most of my functions in. So that KM sleep gives it 100 milliseconds to just for everything to start, everything to start after the program starts. I have the following functions: read the change and acceleration of the container along the X, Y, and Z axis. So I've done those all separately. So I would, with the BLE, I would do separate read and writes for the X, Y, and Z accelerometers. If the connection is active and if the step count value is not equal to the old step count, then the program here sets the old step count value to be equal to the step count value. I'm trying to scroll on. Let me scroll down. And this is where I put my timer in. So the timer starts as the system starts. I've set start time, current time, and elapsed time as unsigned 64-bit integers. Get the system uptime in milliseconds at the start. So start time is set by that kernel function, k uptime get. So k uptime get is a function it's in Zephyr. I think it's in kernel of Zephyr, and that variable or that value is stored at the start time. And then the monitor prints logging started. And then another while loop for the timer. It's set so it's the current time is set as k uptime get, and then elapsed time is set to be current time minus start time divided by 1,000, which is so converting that into seconds, and then that is printed. And then it waits one more second to print again. So the monitor will set by second, so by the second. I'll run that now. So West build -b build BBC microbit v2 for the BBC microbit v2 that we're using. BLE underscore step count is the name of the file, and -p for pristine. West flash to run it. I'll open the accessories serial port terminal. I'll move it over here so it's in view. Configuration port ACMO, and elapsed time goes up by the second, and now I'll the accelerometer. Hit the number of containers when hit number 1, 2. I have that resolution set fairly high, 3, 4, 5. And so now, so that step counter is working. So now I'll go on to my, what do you call it? Onto my app, my BLE app, that BLE scanner app. For some reason hasn't been working perfectly for me, so I download this light blue app. I'll take 1 or 2 of the matrix reads just to show you. So I've hit that twice, and I'll hit these twice. So this is the X accelerometer. This is the Y. I'll hit that twice as well just to show that this is all working. And the Z. And the step count as well. That will read the step counter. Let's now go back to the camera. I'll go up in the terminal. The first thing I did was connected, so I've printed out that I was connected over Bluetooth. I pressed the matrix read twice. That's at 0 because the LEDs are off. If I was to turn that on, that would be at the full value. And elapsed time in between, and I got 2 readings of the accelerometer on the x-axis, 2 on the y-axis, 2 on the z-axis, and I took 1 reading of the hit counter, and now timer is still going and step counter still working. I will show you the dump flash. I didn't change it too much. I didn't really change very much at all. I don't think I changed that at all. I will show you running just the extent that I have it working at, but I couldn't really get it working properly now. Dump underscore. Dump flash. And where's flash? And material, terminal ports. Yeah. So as it is set in the code, everything is at 0. I'll press A. And it goes to 30. Sometimes it goes to 30, sometimes it goes to 40. When I press it, it doesn't seem to be... I couldn't really explain to you how that works, and it doesn't really... The way I have it now doesn't seem to be properly related to my program. So that's why I just seem to be getting random values when I press A. When I press B, it clears. So the clear is working, but the actual log itself isn't really working for the dumb flash, I'm afraid. Yeah, and that's everything. I think that's as far as I got. I tried to do the data log and I just couldn't get it working, and I'm sort of out of time now, so that's everything. That's as far as I've gotten with this. I didn't really get much of a chance with the pulse view analyzer either. Yeah, that's everything. Thanks very much, Frank. I'll submit this now to you. Thanks very much.